Hello and welcome back to G Fun Facts Online. Get ready to have your minds blown, because today we're diving into a topic that sounds like pure science fiction, but is rapidly becoming science fact. We're talking about robots that can design their own hardware. This revolutionary concept is called Robomorphic Computing, and it's poised to fundamentally change our world and the very nature of machines. Imagine robots that don't just follow programs, but can actually reshape their own electronic brains and even their bodies to tackle new challenges. Sounds incredible, right? Let's explore. So you might be wondering, why do we even need robots to design their own internal hardware? Well, traditional robot design often uses a one-size-fits-all approach with general-purpose processors. But as robots get more complex and are sent into all sorts of dynamic environments, this generic hardware just can't keep up. Think about it. A robot navigating a disaster zone has vastly different needs than one assembling delicate electronics. Using the same generic brain for both is like trying to run a marathon in hiking boots, not very efficient. Robomorphic computing aims to fix this by creating hardware perfectly tailored to a robot's specific body and job, making them faster, smarter, and more effective. How on earth does a robot design its own hardware? It's not magic, but it's incredibly clever. Robomorphic computing is essentially a design methodology. It starts by looking at a robot's physical structure, its limbs, joints, how it moves. This information is translated into mathematical forms, often matrices. Now, these matrices usually have a lot of blank spots or zeros, representing movements the robot simply can't make due to its design. Instead of wasting energy processing these zeros, Robomorphic computing helps design specialized hardware that focuses only on the meaningful data, the non-zero values. This makes computations incredibly fast and efficient. And who are the star players in this design revolution? You guessed it, artificial intelligence and machine learning. Generative AI tools can dream up countless hardware layouts, while evolutionary algorithms can evolve these designs to meet specific performance goals. The ultimate aim is to make hardware almost as flexible and codable as software, allowing robots to reconfigure their internal circuitry, or perhaps even their physical form, on the fly. This isn't just theory. Some amazing technologies are making robomorphic computing a reality. Field programmable gate arrays, or FPGAs, are a key component. Think of them as chameleon chips that can be reprogrammed after they're manufactured, making them perfect for testing these custom hardware designs. We're also seeing the rise of AI accelerators like tensor processing units, TPUs, which are already demonstrating the power of hardware specialized for AI tasks. And then there's evolvable hardware, a field that uses evolutionary algorithms to create specialized electronics, sometimes even allowing hardware to adapt itself at runtime. It's a convergence of cutting-edge tech. Okay, this is super cool, but what does it mean for the real world? The impact of robots designing their own hardware is vast and transformative. We're looking at next-generation robots that are significantly faster, more efficient, and incredibly adaptable. This could mean robots capable of providing frontline medical care to contagious patients, assisting in elder care, or safely handling hazardous materials. Autonomous systems like self-driving cars and drones will benefit hugely from custom hardware optimized for real-time decision-making in unpredictable situations. Imagine space exploration robots that can adapt their hardware to unknown and harsh alien environments, or personalized medical devices and prosthetics perfectly tailored to individual patient needs. Even manufacturing and logistics will see a revolution, with factory robots dynamically adapting their hardware for new products or optimized workflows. Now, it's not all smooth sailing. Creating robots that can design and modify their own hardware comes with significant challenges. The design and verification process is incredibly complex. Ensuring these systems are safe, reliable, and predictable, especially when they interact with humans, is a monumental task. The computational power needed for AI to design and simulate new hardware can also be immense. And, of course, there are ethical considerations. What about job displacement if AI automates hardware design? Who is accountable if an autonomously designed system makes an error? And what are the unforeseen consequences of highly adaptable intelligent machines? These are questions we need to address carefully as this technology develops. So what's on the horizon for robomorphic computing? The journey is just beginning, and the future looks even more astounding. We can expect AI to take on even more significant roles in the entire hardware design lifecycle, potentially leading to self-evolving products that learn and adapt throughout their operational life. Some researchers are even exploring AI-driven morphogenesis, where AI could influence the physical design and self-assembly of robots, much like biological organisms develop. Advances in new materials and 3D printing of electronics could allow for rapid creation of these custom components. For this to truly flourish, the whole tech ecosystem needs to adapt with standardized interfaces and accessible tools. Robomorphic computing is more than just a new engineering approach. It's a fundamental rethinking of the relationship between a robot's mind and its body. By enabling robots to participate in the design of their own hardware, we are unlocking the potential for machines that are not only more intelligent, but also intrinsically suited to the tasks they perform and the worlds they inhabit. The era of static, predetermined hardware is giving way to a future of dynamic, self-optimizing, and ultimately, self-designing robotic systems. It truly is the dawn of self-shaping machines. That's all the time we have for today on Fun Facts Online. I hope you found this glimpse into the future of robotics as fascinating as I did. Join us next time for more amazing insights and fun facts from the world of science and technology. Don't forget to subscribe so you don't miss out.